Ya para todos de Ya, que es una empresa académica de nuestro mentor, ¿cómo se llama? Andrew G. La idea es que ustedes tengan acceso, que podamos ver los videos, podamos discutir, podamos intercambiar opiniones y tener una idea sobre sobre la inteligencia artificial en el día de hoy, en el momento ahora. Un segundito, por favor, voy a cerrar la puerta.
Hola, buenas tardes.
Ya para todos, Ya, es una empresa académica de nuestro mentor,
Andrew en sí.
La idea es que ustedes tengan acceso, que podamos ver los videos, podamos discutir, podamos intercambiar opiniones y tener una idea sobre sobre la inteligencia artificial en el día de hoy, en el momento ahora. Un segundito, por favor.
Hola, buenas tardes.
Hola, ¿qué tal? Disculpen, ¿ahora se escucha? Ariel, ¿me estás escuchando?
Sí, sí, yo te escucho bien. Lo que pasa es que está entrando mucha gente.
Bueno, y yo voy a empezar a compartir, a ver si puedo.
Andrew en sí.
Ahí estoy escuchando el mismo audio.
Ahora sí. Perdón, Ahora estamos bien, Emiliano.
¿Sí me están escuchando? ¿Se
Sí,
escucha?
sí, dicen que se escucha un poquito bajo. Estoy leyendo por
Bueno,
el chat.
ahí está, ahora voy a subir un poquito el micrófono.
Yo igual te escucho bien, pero a lo mejor yo tengo el volumen un poquito alto.
Bueno, ahora ahí cómo me escuchan, ¿muy
Ahora
alto?
sí, ahora se escucha bien,
Bueno, igual la idea, bueno, yo voy a hablar, obviamente, pero la idea es empezar con este curso. Vamos a hacer hoy la semana 1 del curso de Ya para Todos, de Andrew Ng, que es el creador de Coursera y el creador de DPI, y es un referente mundial de todo lo que sea inteligencia artificial. Lo habrán visto si googlearon una vez noticias sobre inteligencia artificial, que aparecen muchas veces. Entonces lo que vamos a ver es un curso no técnico, significa que no vamos a ver cosas técnicas específicas, sino vamos a ver las teorías, vamos a ver los conceptos para que nos queden claros la inteligencia artificial, qué es lo que se puede hacer y lo que no se puede hacer, y vamos a ver conceptos como la ética usando inteligencia artificial y cómo desarrollar una empresa para que use inteligencia artificial y cómo nos podemos valer. Y quitarnos los miedos y todo. Entonces vamos a empezar con el primer video, que yo espero que se vea y se escuche bien, de qué es la inteligencia artificial.
Emiliano,
Sí, sí, Ariel.
hago una pequeña introducción.
Sí.
Yo voy a estar, ¿qué tal? Mi nombre es Ariel Alegre, la verdad que con Emiliano vamos a estar esta semana con ustedes, ayudándolos y acompañándolos. Espero que les resulte productivo y útil y un poco divertido también. Como contaba Emiliano, vamos a estar viendo el curso Inteligencia Artificial para Todos y vamos a estar también volcando un poco nuestras impresiones de la experiencia de estos años de trabajar en temas de inteligencia artificial. Hay un montón de gente, hay ya más de 70 personas, hay gente también en el canal de YouTube que se está transmitiendo, así que yo les voy a tomar el presente ahora por el grupo de WhatsApp, así que ahora les voy a pasar para los que no están, por acá por el chat del grupo de WhatsApp y también por YouTube, y voy a empezar a tomar los presentes. Yo les voy a poner presente a todos, o sea, no se desesperen. Lo que voy a pasar es una lista parcial y se van agregando. Puede ser que a veces alguno da el presente y yo no lo vi, dice, di 3 veces. Bueno, no importa, lo vuelve a dar y yo lo tomo, ¿sí? Y la idea es que esa gente es a la que vamos a invitar mañana, o sea, este curso va a ser lunes, martes, jueves y viernes. El miércoles no, porque va a haber una charla de Python que va a dar Ariel Tenon, así que por eso no vamos a estar dando el miércoles, va a ser lunes, martes, jueves y viernes. Así que yo les voy a pasar el link al grupo de WhatsApp, vamos a tomar el presente por ahí, y despacito vamos a ir tomando los presentes de todos. Así que yo los dejo con Emiliano, que es un capo, él está trabajando desde este mes a full en el Centro de Graduados, está trabajando en varios proyectos y también da clases, así que ha sido una incorporación muy interesante, está colaborando con un montón de cosas, y bueno, espero que también les sirva, por eso lo está haciendo esto, tenemos la posibilidad, porque él se ha incorporado al staff permanente del Centro de Graduados. Bueno, los dejo con Emiliano Pasarello.
Bueno, y yo, en carácter transitivo, los voy a dejar con Andrew G y vamos a empezar a ver el primer video de la semana 1 y después me gustaría que si alguien quiere hacer un comentario se desmutee y se vuelva a mutear, y la idea es que participemos, que demos nuestras impresiones y nuestras opiniones y que vayamos haciendo como una conversación, aunque sea virtual, que no nos podamos ver la cara, pero la idea es esa. Bueno, empecemos. Voy a poner pantalla completa y está subtitulado.
Welcome to AI for Everyone. AI is changing the way we work and live, and this non-technical course will teach you how to navigate the rise of AI. Whether you want to know what's behind the buzzwords, or whether you want to perhaps use AI yourself, either in a personal context or in a corporation or other organization, this course will teach you how. And if you want to understand how AI is affecting society and how you can navigate that, you also learn that from this course. In this first week, we'll start by cutting through the hype and giving you a realistic view of what AI really is. Let's get started. You've probably seen news articles about how much value AI is creating. According to a study by McKinsey Global Institute, AI is estimated to create an additional $13 trillion of value annually by the year 2030. Even though AI is already creating tremendous amounts of value in the software industry, a lot of the value to be created in the future lies outside the software industry in sectors such as retail, travel, transportation, automotive, materials, manufacturing, and so on. I should have a hard time thinking of an industry that I don't think AI will have a huge impact on in the next several years. My friends and I used to challenge each other to name an industry where we don't think AI will have a huge impact. And my best example was the hairdressing industry, because how to use AI or robotics to automate hairdressing. But I once said this on stage, and one of my friends who is a robotics professor was in the audience that day, and she actually stood up and she looked at me in the eye and she said, Andrew, most people's hairstyles, I couldn't get a robot to cut their hair that way. But she looked at me and said, your hairstyle, Andrew, that a robot can do. There is a lot of excitement, but also a lot of unnecessary hype about AI. One of the reasons for this is because AI is actually two separate ideas. Almost all the progress we are seeing in AI today is artificial narrow intelligence. These are AIs that do one thing, such as a smart speaker or self-driving car, or AI to do web search, or AI applications in farming or in a factory. These types of AI are one-trick ponies, but when you find the appropriate trick, this can be incredibly valuable. Unfortunately, AI also refers to a second concept of AGI, or artificial general intelligence. That is the goal, to build AI that can do anything a human can do, or maybe even be super intelligent and do even more things than any human can. I'm seeing tons of progress in ANI, artificial narrow intelligence, and almost no progress toward AGI, or artificial general intelligence. Both of these are worthy goals, and unfortunately, the rapid progress in ANI, which is incredibly valuable, that has caused people to conclude that there's a lot of progress in AI, which is true, but that has caused people to falsely think that there might be a lot of progress in AGI as well, which is leading to some irrational fears about evil killer robots coming over to take over humanity anytime now. I think AGI is an exciting goal for researchers to work on, but it'll take multiple technological breakthroughs before we get there, and it may be decades or hundreds of years or even thousands of years away. Given how far away AGI is, I think there is no need to unduly worry about it. In this week, you will learn what ANI can do and how to apply them to your problems. Later in this course, you'll also see some case studies of how ANI, these one-trick ponies, can be used to build really valuable applications such as smart speakers and self-driving cars. In this week, you will learn what is AI. You may have heard of machine learning, and the next video will teach you what is machine learning. You also learn what is data and what types of data are valuable, but also what types of data are not valuable. You learn what it is that makes a company an AI company or an AI first company, so that perhaps you can start thinking if there are ways to improve your company or other organizations' ability to use AI. And importantly, you also learn this week what machine learning can and cannot do. In our society, newspapers as well as research papers tend to talk only about the success stories of machine learning and AI, and we hardly ever see any failure stories because they just aren't as interesting to report on. But for you to have a realistic view of what AI and what machine learning can and cannot do, I think it is important that you see examples of both so that you can make more accurate judgments about what you may and maybe should not try to use these technologies for. Finally, a lot of the recent rise of machine learning has been driven through the rise of deep learning, sometimes also called neural networks. In the final two optional videos of this week, you can also see an intuitive explanation of deep learning so that you will better understand what they can do, particularly for a set of narrow ANI tasks. So that's what you learn this week. And by the end of this week, you have a sense of AI technologies and what they can and cannot do. In the second week, you learn how these AI technologies can be used to build valuable projects. You learn what it feels like to build an AI project, as well as what you should do to make sure you select projects that are technically feasible, as well as valuable to you or your business or other organization. After learning what it takes to build AI projects, in the third week, you learn how to build AI in your company. In particular, if you want to take a few steps toward making your company good at AI, you see the AI transformation playbook and learn how to build AI teams and also build complex AI products. Finally, AI is having a huge impact on society. In the fourth and final week, you learn about how AI systems can be biased and how to diminish or eliminate such biases. You also learn how AI is affecting developing economies and how AI is affecting jobs, and be better able to navigate this rise of AI for yourself and for your organization. By the end of this 4-week course, you'll be more knowledgeable and better qualified than even the CEOs of most large companies in terms of your understanding of AI technology, as well as your ability to help yourself or help your company or other organization navigate the rise of AI. And so I hope that after this course, you'll be in a position to provide leadership to others as well as they navigate these issues. Now, one of the major technologies driving the recent rise of AI is machine learning. But what is machine learning? Let's take a look in the next video.
En este primer video lo que vimos es una introducción, nos explica qué vamos a ver en todas las distintas semanas, ¿no? En esta primera semana vamos a ver demistificar vamos a desmitificar la inteligencia artificial y los miedos que genera la inteligencia artificial general, y vamos a conocer los conceptos básicos del aprendizaje automático. Y bueno, seguimos. Y si alguien quiere hacer un comentario, alguna duda, puede preguntar, Ariel y yo estamos dispuestos a... Bueno, continuamos.
¿Qué tal, Emiliano?
Sí, sí.
Sí, ¿será posible poner las primeras imágenes del video de vuelta solo para hacerle una captura de pantalla a ese gráfico que mostró desde el principio de todo?
A ver, ¿qué gráfico?
Que decía AI, AH, tenía un par de siglas.
¿Al principio de todo?
Por ahí era el primer minuto, los primeros 2 minutos.
ANI y AGI.
Esa parte.
Ah, sí, que en la traducción no. La inteligencia artificial, cuando hablaba de la inteligencia artificial general y la estrecha.
Exacto.
Acá tenemos. Igual.
Este gráfico. Ahí cuando.
Ahí está.
Ahí
La
va.
inteligencia artificial en general, está la inteligencia artificial estrecha, que en castellano es con la E, y la general. La estrecha es cuando una inteligencia artificial está diseñada para hacer un tipo de actividad que lo hace bien. Pero, por ejemplo, entrenar un clasificador que clasifique si un objeto está dañado o no, va a andar bien. Pero si le decís preparame un café, no te lo va a hacer. ¿Entendés? La inteligencia artificial general es la típica de la ciencia ficción. Sería Terminator, ¿no? Generar humanoides que puedan resolver todo. Y en realidad la inteligencia artificial, para llegar a eso, faltaría muchísimo. Tendría que juntar mucho más. Es casi, no sé, yo no soy, diría irreal, porque la gente que hace unos años pensaba que no podía haber un traductor automático de inglés a castellano, ¿entendés? Que siempre iba a necesitar un traductor, una persona que traduzca. Ahora, con los traductores que hay, se pueden sorprender, ¿no? No lo hubieran imaginado, y son inteligencias artificiales. Así que no diría que no pueda suceder nunca, pero yo creo que está muy lejos. Y más cuando vas conociendo todos los conceptos porque como dijo Andrew en el video, siempre conocemos los éxitos de la inteligencia artificial. Nos muestran cuando un algoritmo, cuando una red neuronal hace algo bien, pero no te muestran todas las que fracasan, ¿no? Que son un montón. Eso porque no son interesantes, ¿no? Bueno, vamos a seguir a ver si...
Perfecto, muchas gracias.
No, esto no sé qué pasó acá. ¿Alguien dibujó la...? ¿Se ve bien ahí? ¿Se ve todo? A ver.
The rise of AI has been largely
¿Se ve bien o están viendo un cuadrado así con un dibujo?
Sí, se ve como
Alguien-
una rayita ahí.
Alguien hizo una pizarra. No sé quién, no sé cómo sacarlo eso. ¿Le molesta? Porque va a quedar todo el curso. A ver si dejo de compartir y vuelvo a compartir. Ahí está.
driven by one tool in AI called machine learning.
Listo. No se ve ahora, ¿no?
The rise of AI has been largely driven by one tool in AI called machine learning. In this video, you learn what is machine learning so that by the end, you hopefully be able to start thinking how machine learning might be applied to your company or to your industry. The most commonly used type of machine learning is a type of AI that learns A to B or input to output mappings. And this is called supervised learning. Let's see some examples. If the input A is an email and the output B you want is this email spam or not, 0 or 1, then this is the core piece of AI used to build a spam filter. Or if the input A is an audio clip and the AI's job is to output the text transcript, then this is speech recognition. More examples, if you want to input English and have it output a different language, Chinese, Spanish, something else, then this is machine translation. Or the most lucrative form of supervised learning of this type of machine learning may be online advertising, where all the large online ad platforms have a piece of AI that inputs some information about an ad and some information about you and tries to figure out will you click on this ad or not. And by showing you the ads that you're most likely to click on, this turns out to be very lucrative. Maybe not the most inspiring application, but certainly having a huge economic impact today. Or if you want to build a self-driving car, one of the key pieces of AI is an AI that takes as input an image and some information from the radar or from other sensors and outputs the position of other cars, so your self-driving car can avoid the other cars. Or in manufacturing, I've actually done a lot of work in manufacturing where you would take as input a picture of something you've just manufactured, such as a picture of a cell phone coming off an assembly line. This is a picture of a phone, not a picture taken by a phone. And you want to output, is there a scratch or is there a dent or some other defect on this thing you've just manufactured? And this is visual inspection, which is helping manufacturers reduce or prevent defects in the things that they're making. This type of AI, called supervised learning, just learns input to output or A to B mappings. And on one hand, input to output, A to B, seems quite limiting, but when you find the right application scenario, this can be incredibly valuable. Now, the idea of supervised learning has been around for many decades, but it's really taken off in the last few years. Why is this? When my friends ask me, hey Andrew, why is supervised learning taking off now? There's a picture I draw for them, and I want to show you this picture now. And you may be able to draw this picture for others that ask you the same question as well. Let's say on the horizontal axis, you plot the amount of data you have for a task. So for speech recognition, this might be the amount of audio data and transcripts you have. In a lot of industries, the amount of data you have access to has really grown over the last couple of decades, thanks to the rise of the internet, the rise of computers. A lot of what used to be, say, pieces of paper are now instead recorded on a digital computer. So we've just been getting more and more data. Now, let's say on the vertical axis, you plot the performance of an AI system. It turns out that if you use a traditional AI system, then the performance would grow like this. That as you feed it more data, its performance gets a bit better, but beyond a certain point, it did not get that much better. So it's as if your speech recognition system did not get that much more accurate, or your online advertising system didn't get that much more accurate at showing the most relevant ads, even as you showed it more data. AI has really taken off recently due to the rise of neural networks and deep learning. I'll define these terms more precisely in a later video, so don't worry too much about what it means for now. But with modern AI, with neural networks and deep learning, what we saw was that if you train a small neural network, then the performance kind of looks like this, whereas you feed it more data, performance keeps getting better for much longer. And if you train a even slightly larger neural network, say a medium-sized neural net, then the performance may look like that. And if you train a very large neural network, then the performance just, kind of keeps on getting better and better. And for applications like speech recognition, online advertising, building a self-driving car, where having a high performance, highly accurate, say, speech recognition system is important, this has enabled these AI systems to get much better and make, say, speech recognition products much more acceptable to users, much more valuable to companies and to users. Now, here are a couple implications of this figure. If you want the best possible levels of performance, your performance to be up here, to hit this level of performance, then you kind of need two things. One is it really helps to have a lot of data. So that's why sometimes you hear about big data. Having more data almost always helps. And the second thing is you want to be able to train a very large neural network. And so the rise of fast computers, including Moore's law, but also the rise of specialized processors, such as graphics processor units or GPUs, which you hear more about in the later video, has enabled many companies, not just the giant tech companies, but many, many other companies, to be able to train large neural nets on a large enough amount of data in order to get very good performance and drive business value. The most important idea in AI has been machine learning, and specifically supervised learning, which means A to B, or input-output mappings. What enables it to work really well is data. In the next video, let's take a look at what is data and what data you might already have and how to think about feeding this into AI systems. Let's go on to the next video.
Bueno, si entendieron que la inteligencia artificial tuvo un crecimiento muy amplio en los últimos tiempos, es gracias a que los datos se hicieron mucho más accesibles. Entonces, siempre lo más importante de una inteligencia artificial, en este caso de una inteligencia artificial, sea machine learning o deep learning, es tener bien los datos, saber bien qué datos. De ahí decía, vamos de A a B, de entrada y salida. Entonces, si nosotros tenemos bien clasificados los datos A con su verdadera clasificación, los datos B, entiende que sí que están bien clasificados, que eso lo tenemos que hacer, se puede hacer manualmente o se puede hacer semiautomático, pero siempre hay que chequear. Entonces, lo más importante de todo esto es tener una buena cantidad suficiente de datos que estén bien. Entonces, la inteligencia artificial va a entrenar con eso. ¿Se entendió, no? Bueno, continúa. Si alguien tiene alguna duda, alguna pregunta, por favor, o algún comentario, lo que sea. Me voy a fijar en el chat. Si alguien en el chat, ¿está todo bien? Bueno, listo. Perfecto.
You may have heard that data is really important for building AI systems, but what is data really? Let's take a look. Let's look at an example of a table of data, which we also call a data set. If you're trying to figure out how to price houses that you're trying to buy or sell, you might collect a data set like this, and this can be just a spreadsheet, like an Excel spreadsheet of data, where one column is the size of the house, say in square feet or square meters, and the second column is the price of the house. And so if you're trying to build an AI system or a machine learning system to help you set prices for houses or figure out if a house is priced appropriately, you might decide that the size of the house is A and the price of the house is B, and have an AI system learn this input to output or A to B mapping. Now, rather than just pricing a house based on the size, you might say, well, let's also collect data on the number of bedrooms of this house. In that case, A can be both of these first two columns, and B can be just the price of the house. So given a table of data, given a data set, it's actually up to you, up to your business use case to decide what is A and what is B. Data is often unique to your business, and this is an example of a data set that a real estate agency might have if they're trying to help price houses. And it's up to you to decide what is A and what is B, and how to choose these definitions of A and B to make it valuable for your business. As another example, if you have a certain budget and you want to decide what is the size of house you can afford, then you might decide that the input A is how much does someone spend, and B is just the size of the house in square feet. And that would be a totally different choice of A and B that tells you, given a certain budget, what's the size of a house you should be maybe looking at. Here's another example of a data set. Let's say that you want to build a AI system to recognize cats in pictures. I'm not sure why you might want to do that, but maybe you have a fun mobile app and you want to tag all the pictures of cats. So you might collect a data set where the input A is a set of different images and the output B are labels that says, first picture is a cat, that's not a cat, that's a cat, that's not a cat, and have an AI input a picture A and output B, is it a cat or not? So you can tag all the cat pictures on your photo feed or on your mobile app. In machine learning tradition, there's actually a lot of cats in machine learning. I think some of this started when I was leading the Google Brain team and we published the results with a somewhat infamous Google cat, where an AI system learned to detect cats from watching YouTube videos. But since then, there's been a tradition of using cats as a running example when talking about machine learning. With apologies to all the dog lovers out there. I love dogs too. So data is important, but how do you get data? How do you acquire data? Well, one way to get data is manual labeling. For example, you might collect a set of pictures, like these over here, and then you might either yourself or have someone else go through these pictures and label each of them. So the first one is a cat, second one is not a cat, third one is a cat, fourth one is not a cat. And by manually labeling each of these images, you now have a data set for building a cat detector. To do that, you actually need more than 4 pictures. You might need hundreds or thousands of pictures, but manual labeling is a tried and true way of getting a data set where you have both A and B. Another way to get a data set is from observing user behaviors or other types of behaviors. So for example, let's say you run a website that sells things online. So an e-commerce or an electronic commerce website where you offer things to users at different prices and you can just observe if they buy your product or not. So just through the act of either buying or not buying your product, you may be able to collect a data set like this, where you can store the user ID, the time the user visited your website, the price you offer the product to the users, as well as whether or not they purchased it. And so just by using your website, users can generate this data from you. This was an example of observing user behaviors. We can also observe behaviors of other things, such as machines. If you run a large machine in a factory and you want to predict if a machine is about to fail or have a fault, then just by observing the behavior of a machine, you can then record a data set like this. There's a machine ID, there's the temperature of the machine, there's a pressure within the machine, and then did the machine fail or not? And if your application is preventative maintenance, say you want to figure out if a machine is about to fail, then you could, for example, choose this as the input A and choose that as the output B to try to figure out if a machine is about to fail, in which case you might do maintenance, preventative maintenance on the machine. The third and very common way of acquiring data is to download it from a website or to get it from a partner. Thanks to the open internet, there's just so many data sets that you can download freely, ranging from computer vision or image data sets to self-driving car data sets to speech recognition data sets to medical imaging data sets to many, many more. And so if your application needs a type of data you just download off the web, keeping in mind licensing and copyright, then that could be a great way to get started on an application. And finally, if you work with a partner, say you're working with a factory, then they may already have collected a big data set of machines and temperatures and pressure, and did the machines fail or not, that they could give to you. Data is important, but it's also a little bit overhyped and sometimes misused. Let me describe to you two of the most common misuses or the bad ways of thinking about data. When I speak with CEOs of large companies, a few of them have actually said to me, "Hey Andrew, give me 3 years to build up my IT team. We're collecting so much data. And then after 3 years, I'll have this perfect data set, and then we'll do AI then." It turns out that's a really bad strategy. Instead, what I recommend to every company is once you started collecting some data, go ahead and start showing it or feeding it to an AI team, because often the AI team can give feedback to your IT team on what types of data to collect and what types of IT infrastructure to keep on building. For example, maybe an AI team can look at your factory data and say, "Hey, you know what? If you can collect data from this big manufacturing machine, not just once every 10 minutes, but instead once every 1 minute, then we could do a much better job building a preventative maintenance system for you." So there's often this interplay of this back and forth between IT and AI teams. And my advice is usually try to get feedback from AI earlier, because it can help you guide the development of your IT infrastructure. Second misuse of data. Unfortunately, I've seen some CEOs read about the importance of data in the news and then say, "Hey, I have so much data, surely an AI team can make it valuable." And unfortunately, this doesn't always work out. More data is usually better than less data, but I wouldn't take it for granted that just because you have many terabytes or gigabytes of data that an AI team can magically make that valuable. So my advice is don't throw data in an AI team and assume it will be valuable. In fact, in one extreme case, I saw one company go and acquire a whole string of other companies in medicine on the thesis, on the hypothesis that their data would be very valuable. And now, a couple of years later, as far as I know, the engineers have not yet figured out how to take all this data and actually create value, all of it. So sometimes it works and sometimes it doesn't, but I would not overinvest in just acquiring data for the sake of data unless you're also getting an AI team to take a look at it, because they can help guide you to think through what is the data that is actually the most valuable. Finally, data is messy. You may have heard the phrase garbage in, garbage out, and if you have bad data, then the AI will learn inaccurate things. Here are some examples of data problems. Let's say you have this data set of size of houses, number of bedrooms, and the price. You can have incorrect labels or just incorrect data. For example, this house is probably not going to sell for $0.001,000, just for $1. Or data can also have missing values, such as we have here a whole bunch of unknown values. And so your AI team will need to figure out how to clean up the data or how to deal with these incorrect labels and or missing values. And there are also multiple types of data. For example, sometimes you hear about images, audio, and text. These are types of data that humans find it very easy to interpret. There's a term for this. This is called unstructured data. And there's certain types of AI techniques that could work with images to recognize cats, or audio to recognize speech, or text to understand if an email is spam. And then there are also data sets like the one on the right. This is an example of structured data, and that basically means data that lives in a giant spreadsheet. And the techniques for dealing with unstructured data are a little bit different than the techniques for dealing with structured data. But AI techniques can work very well for both of these types of data, unstructured data and structured data. In this video, you learned what is data, and you also saw how not to misuse data, for example, by over-investing in an IT infrastructure in the hope that it will be useful for AI in the future, but without actually checking that it really will be useful for the AI applications you want to build. And finally, you saw data is messy, but a good AI team will be able to help you deal with all of these problems. Now, AI has a complicated terminology where people throw around terms like AI, machine learning, data science. What I want to do in the next video is share with you what these terms actually mean so that you'll be able to confidently and accurately talk about these concepts with others. Let's go on to the next video.
Bueno, ¿Alguien quiere opinar? ¿Tiene alguna pregunta sobre el tema? Pero sí, sí, escucho. Pero bueno, lo
Emiliano,
que... Sí, sí,
¿cómo te va?
¿qué tal? ¿Cómo andas tanto tiempo?
Muy bien, tanto tiempo, sí. El equipo de inteligencia artificial tendría o debería estar encargándose de la depuración de los datos de toda la base o daría las recomendaciones para que otro equipo se encargara de esa tarea, porque entiendo que debería haber una definición de homologación o de calidad para decir, bueno,
En realidad es como es muy ambiguo. En realidad deberían trabajar en conjunto, porque vos estás haciendo un analista de datos, va a recoger los datos y va a depurar y va a sacar. Pero tendría que consultar con el ingeniero de inteligencia artificial qué datos necesita para el algoritmo. Y a su vez, es que no es que uno le va a indicar al otro, sino compartir conocimientos. No es como que está separado esto. Esto está en progreso, ¿no? Es todo muy fresco, está todo en progreso. Entonces, las tareas no están muy bien definidas. Sí, los analistas de datos recolectan, guardan, analizan, grafican los datos para pero como decía, juntar datos por juntar datos no sirve de mucho si no sabes qué es lo que el algoritmo que datos va a usar. ¿Entendemos? Entonces, es como que hay que trabajar en conjunto. Pero sí, se supone que una sola persona no se puede encargar de todo. Aunque al principio Andrew nos va a anticipar que capaz que puede haber un equipo de una sola persona o dos personas. Se puede empezar. No hay una, ¿cómo se llama? Nosotros cuando empezamos un trabajo que estábamos haciendo, tuvimos que etiquetar, tuvimos que clasificar, tuvimos que hacer todo nosotros. ¿Entendés? Después con el tiempo sí podés empezar a recurrir a otras cosas. Tenés que ver qué tipo de datos vas a necesitar. Entonces, no sé si, Gustavo, si me entendiste lo que te quise decir o generé alguna duda más.
no, perfecto, Emiliano, se entiende. Y
Lo que hablaba es
esperaría
que,
a que progreso esto, sí.
¿cómo?
Esperaría que siga progresando, pero sí, te entendí.
Claro, la idea es que esto es va avanzando, ¿viste? Entonces, eh, la inteligencia artificial no tiene los algoritmos hace poquito, que se están, no es que tiene 20 años de trayectoria. Entonces, igual el análisis de datos tampoco, porque todo esto empieza cuando se empiezan a acumular datos, empezamos a acumular datos de la explosión de Internet. ¿Entendés? Que hace cuánto, a lo sumo 20 años, 25, 30 años, que, pero a medida que tenemos mayor capacidad para guardar datos, base de datos, que, que podemos guardar videos, imágenes, audios y todas esas cosas, eh, se van generando estas incertidumbres y se van generando el analista de datos, el científico de datos, el ingeniero en inteligencia artificial, que todo puede caer en una sola persona que se encargue de todo, o después especializarse en algún tema en específico. Lo importante acá es que tenemos varios métodos para conseguir datos. Uno es era el etiquetando, el otro era el hecho de que sacarle al usuario. Entonces, cuando nosotros eh, tenemos algo que es gratis, nada es gratis. En realidad, el producto somos nosotros, entonces nos están tratando de sacar, somos útiles para sacar información. ¿Se entiende? Entonces, bueno, eh, ¿alguien tiene algún otro comentario, alguna duda o quedó todo claro? Seguimos avanzando.
Comentaron una duda en el chat que se ve que vino de YouTube.
Sí, te pasé una pregunta sobre la cantidad de datos.
Y bueno, dice que cuanto mayor cantidad de datos, mejor, pero no necesariamente. Depende. Tener datos, como dice, como vimos en el video anterior, el gráfico, llegó un momento que tener más datos no aumentaba el rendimiento del algoritmo. Así que no.
No, yo un poco lo que quería agregar, Emiliano, que
Sí,
en lo que es el machine learning tradicional, antes de los modelos de deep learning, se hablaba a lo mejor de tener 1000 datos, 5000 datos, 10.000 datos. Y en los modelos de Big Data, donde vos ya tenés redes neuronales, ahí a lo mejor tenés 100 millones de datos. Como para dar una idea del orden, que me da la impresión que es un poco lo que preguntaba Pablo, ¿sí? O sea, es como que en las grandes redes neuronales siempre te faltan datos. Por eso se hacen un montón de técnicas para aumentar artificialmente la cantidad de datos, girándolas o cambiándoles un poquito el color, ¿no? Eso es lo que se llama data augmentation, ¿sí? Siempre te faltan. Como para tener una idea del orden, que me da la impresión que eso es lo que... Emiliano, sí, dale.
Disculpen,
Sí.
no se me ocurre, capaz que sea redundante lo que voy a decir, no, pero más allá de la cantidad de datos que se tenga, lo más importante a mi punto de vista es la clasificación y la especificación de los datos, o sea, tener bien identificados los datos, no tener datos por tener, sino que estén bien clasificados y bien especificados qué tipo de datos son cada uno para su uso.
y sí, lo dijo en el video, si entra basura, sale basura. Si vos tenés
Claro, lo que pasa, bien clasificado, perdón, Emiliano, que me meta.
Sí, está bien.
Pasa que vos tenés la fuente de datos, tenés que clasificar, como decís, claramente los datos, pero quizá tu fuente de datos tenés que ver y hacer algún análisis previo porque tenés una sola fuente o tenés varias. Entonces la fuente de datos es importante, la clasificación es importante y obviamente también la cantidad en algún punto, ¿no?
Sí.
Vamos a incorporar un pequeño tema administrativo.
Bueno,
Les quería pedir a los que todavía no se agregaron, les mando por acá el grupo de WhatsApp. Estamos tomando el presente por ahí. ¿Sí? Les paso por ahí ahí está, ahí les estoy pasando el link al grupo de WhatsApp y lo voy a también pasar ahora por YouTube. ¿Sí? Por ahí estamos tomando el presente. Yo ahora les voy a empezar a pasar por el grupo de WhatsApp la lista que tengo, que son más o menos 50. Todavía faltan unos 40 presentes. Me van agregando y no es que, puede ser que alguno dio el presente al principio y no lo vi, pero bueno, simplemente lo agrego, ¿ok?
ok, proseguimos entonces, vamos a ver la terminología sobre del IA. ¿Ah?
You might have heard terminology from AI such as machine learning or data science or neural networks or deep learning. What do these terms mean? In this video, you'll see what is this terminology of the most important concepts of AI so that you will speak with others about it and start thinking how these things could apply in your business. Let's get started. Let's say you have a housing data set like this with the size of the house, number of bedrooms, number of bathrooms, whether the house is newly renovated, as well as the price. If you want to build a mobile app to help people price houses, so this would be the input A, and this would be the output B, then this would be a machine learning system. In particular, it'd be one of those machine learning systems that learns input to output or A to B mappings. So machine learning often results in a running AI system. So it's a piece of software that any time of day, any time of night can automatically input A, these properties of a house, and outputs B. So if you have an AI system running, serving dozens or hundreds or thousands of millions of users, that's usually a machine learning system. In contrast, here's something else you might want to do, which is to have a team analyze your data set in order to gain insights. So a team might come up with a conclusion like, hey, did you know if you have two houses of a similar size, of a similar square footage, if the house has 3 bedrooms, then they cost a lot more than the house with 2 bedrooms, even if the square footage is the same. Or did you know that newly renovated homes have a 15% premium? And this could help you make decisions such as, given a similar square footage, do you want to build a 2-bedroom or a 3-bedroom size in order to maximize value? Or is it worth an investment to renovate a home in the hope that the renovation increases the price you can sell a house for? So these would be examples of data science projects, where the output of a data science project is a set of insights that can help you make business decisions, such as what type of house to build or whether to invest in renovation. The boundaries between these two terms machine learning and data science are actually a little bit fuzzy, and these terms are not used consistently even in industry today. But what I'm giving here is maybe the most commonly used definitions of these terms, but you will not find universal adherence to these definitions. To formalize these two notions a bit more, machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. This is a definition by Arthur Samuel many decades ago. Arthur Samuel was one of the pioneers of machine learning who was famous for building a checkers playing program that could play checkers even better than he himself, the inventor, could play the game. So a machine learning project will often result in a piece of software that runs, that outputs B given A. In contrast, data science is the science of extracting knowledge and insights from data. And so the output of a data science project is often a slide deck, like a PowerPoint presentation that summarizes conclusions for executives to take business actions, or that summarizes conclusions for a product team to decide how to improve a website. Let me give an example of machine learning versus data science in the online advertising industry. Today, the large ad platforms all have a piece of AI that quickly tells them what's the ad you are most likely to click on. So that's a machine learning system, and this turns out to be incredibly lucrative. AI system that inputs information about you and about the ad and outputs will you click on this or not. These systems are running 24/7, and these are machine learning systems that drive ad revenue for these companies. So there's a piece of software that runs. In contrast, I've also done data science projects in the online advertising industry. If analyzing data tells you, for example, that the travel industry is not buying a lot of ads, but if you send more salespeople to sell ads to travel companies, you could convince them to use more advertising. Then that would be an example of a data science project and the data science conclusion that results in executives deciding to ask the sales team to spend more time reaching out to the travel industry. So even in one company, you may have different machine learning and data science projects, both of which can be incredibly valuable. You may have also heard of deep learning. So what is deep learning? Let's say you want to predict housing prices. You want to price houses. So you have an input that tells you the size of the house, number of bedrooms, number of bathrooms, and whether it's newly renovated. One of the most effective ways to price houses, given this input A, would be to feed it to this thing here in order to have it output the price. This big thing in the middle is called a neural network, and sometimes we also call it an artificial neural network. And that's to distinguish it from the neural network that is in your brain. So the human brain is made up of neurons, and so when we say artificial neural network, that's just to emphasize that this is not the biological brain, but instead it's a piece of software. And what a neural network does, or an artificial neural network does, is takes this input A, which is all of these four things, and then output B, which is the estimated price of a house. Now, in a later optional video this week, I'll show you more what this artificial neural network really is. But all of human cognition is made up of neurons in your brain passing electrical impulses, passing little messages to each other. And when we draw a picture of an artificial neural network, there's a very loose analogy to the brain. And these little circles are called artificial neurons, or just neurons for short, that also passes neurons to each other. And this big artificial neural network is just a big mathematical equation that tells it, given the inputs A, how do you compute the price B? In case it seems like there are a lot of details here, don't worry about it. We'll talk more about these details later. But the key takeaways are that a neural network is a very effective technique for learning A to B or input to output mappings. And today, the terms neural network and deep learning are used almost interchangeably. They mean essentially the same thing. Many decades ago, this type of software was called a neural network, but in recent years, we found that, deep learning was just a much better sounding brand. And so that, for better or worse, is the term that's been taking off recently. So what do neural networks or artificial neural networks have to do with the brain? it turns out almost nothing. Neural networks were originally inspired by the brain, but the details of how they work are almost completely unrelated to how biological brains work. So I was very cautious today about making any analogies between artificial neural networks and the biological brain, even though there was some loose inspiration there. So AI has many different tools. In this video, you learned about what are machine learning and data science, and also what is deep learning and what's a neural network. You might also hear in the media other buzzwords like unsupervised learning, reinforcement learning, graphical models, planning knowledge graph, and so on. And you don't need to know what all of these other terms mean, but these are just other tools for getting AI systems to make computers act intelligently. And I try to give you a sense of what some of these terms mean in later videos as well. But the most important tools that I hope you know about are machine learning and data science, as well as deep learning and neural networks, which are a very powerful way to do machine learning and sometimes data science. If we were to draw a Venn diagram showing how all these concepts fit together, this is what it might look like. AI is this huge set of tools for making computers behave intelligently. Of AI, the biggest subset is probably tools from machine learning, but AI does have other tools than machine learning, such as some of these buzzwords listed at the bottom. And of machine learning, the part of machine learning that's most important these days is neural networks or deep learning, which is a very powerful set of tools for carrying out supervised learning or A to B mappings, as well as some other things. But there are also other machine learning tools that are not just deep learning tools. So how does data science fit into this picture? There is inconsistency in how the terminology is used. Some people will tell you data science is a subset of AI. Some people will tell you AI is a subset of data science. It depends a bit on who you ask. But I would say that data science is maybe a cross-cutting subset of all of these tools that uses many tools from AI, machine learning, and deep learning, but has some other separate tools as well that solves a very set of important problems in driving business insights. In this video, you saw what is machine learning, what is data science, and what is deep learning and neural networks. I hope this gives you a sense of the most common and important terminology used in AI, and you can start thinking about how these things might apply to your company. Now, what does it mean for a company to be good at AI? Let's talk about that in the next video.
Bueno, ahora me parece que quedó un poquito más claro la pregunta que había hecho Gustavo, si había quién manejaba la inteligencia artificial o el analista de datos. Lo dijo Andrew, es algo muy confuso, es en medio, pero se pueden separar muy bien. Igual, Ariel, me gustaría, porque habló de la ciencia de datos, de análisis de datos, del deep learning, del machine learning, y estaría bueno, Ariel, si vos estás de acuerdo, en presentar la propuesta que tenemos.
Ah, sí, por supuesto.
Sí,
¿Vos tenés ahí la página?
Sí, espera que salgo de acá.
Dale. Sí, la verdad que estuvimos trabajando bastante para hacer una propuesta completa, interesante. Andá si querés a la primera página, al inicio, a
la página principal.
Para contar un poco rápidamente. Claro. Bueno, básicamente ahí está Omar Facito, que es el presidente de la cooperativa, y básicamente nos identificamos como un grupo de especialistas, gente que nos especializamos en algo, y que nuestro foco está en ayudar a otros profesionales a formarse. Obviamente que hay gente que empezará más de cero, que no será Deep Learning Ingeniería en un año, otros a lo mejor aprenderán Python, empezarán con Data Analytics, pero la idea es una formación que en un lapso relativamente breve les pueda permitir ser empleables o poder trabajar en proyectos de inteligencia artificial. Si bajás un cachito, mostramos un poco. Básicamente nosotros tenemos como 4 líneas de ataque, ¿no? Deep Learning, que vendría a ser nuestro curso tradicional, el curso que venimos dando ya hace varios años, que como decía Emiliano, nos basamos en el curso de Andrew G, la especialización en Deep Learning, que este año lo vamos a dar en 3 etapas, ¿sí? O sea, va a haber una clase los lunes, va a haber una clase los martes y va a haber una práctica los miércoles, un espacio para ustedes, para que puedan practicar y reunirse y seguir profundizando y repasando los ejercicios. El Machine Learning, que hay que aclarar que el Deep Learning forma parte de Machine Learning, pero cuando hablamos de Machine Learning en general, nos estamos refiriendo a todos los algoritmos de inteligencia artificial, de aprendizaje automático, que no son de aprendizaje profundo, ¿sí? Pero hay que aclarar que Deep Learning es una rama, es un subconjunto de Machine Learning. Y ahí también tenemos un curso muy bueno que da Ariel Teno, un curso de 6 clases, donde se ve en profundidad una cantidad de algoritmos bastante completo y que recomiendo que lo hagan los días jueves. Y Data Analytics tenemos varias propuestas, ¿no? Un curso que está arrancando ahora con Python, y otro que es una especialización de Google, que lo hemos desarrollado todo con contenidos propios, que da la ingeniera Marina Siliti, que bueno, Emiliano es egresado de ese curso, ¿no?
Sí. Egresado el año pasado, sí.
Claro. Y bueno, Python, que bueno, de Python hemos hablado mucho y seguiremos hablando porque es la herramienta que usamos para comunicarnos, es lo que usan todos los científicos de datos, todo está en Python, entonces, independientemente que hay muchos lenguajes muy buenos, que se puede trabajar en R o en otros, pero la realidad es que hoy Python es como un paso obligado, ¿no? Y ahora sí, si querés, si pasamos a eso, el cronograma.
Bueno,
Bien, entonces, sí, dale.
No, sí.
Bueno, básicamente subí un cachito.
Sí.
Subí un cachito. Ahí está, básicamente nosotros la propuesta nuestra es a lo largo de este año que ustedes obtengan un certificado profesional. ¿Eso qué significa? Que no serían solo cursos, sino que les dé que ustedes puedan practicar, que puedan hacer un proyecto, que puedan trabajar en algún módulo concreto, que eso les sirva a ustedes para aprender y además para mostrarlo como un trabajo concreto en el que estuvieron participando. Por eso hemos creado una cooperativa de trabajo y por eso estamos trabajando en varios proyectos de inteligencia artificial y por eso queremos invitarlos a los que se sumen a participar en estos proyectos, a ser parte y a meter mano, digamos, concretamente. Básicamente, entonces, en nuestra temporada 2022, ya hay más de 100 estudiantes que han tomado esta propuesta y que están empezando a estudiar, que ya vienen estudiando, pero arranca ahora fuerte. La idea de esta propuesta que les vamos a hacer ahora es que ustedes puedan nombrar un beneficiario, es decir, que puedan acceder a Coursera, a los cursos que hay en Coursera, un beneficiario, es decir, que prácticamente estarían como dividiendo la cantidad de, digamos, de cosas que pueden acceder, o duplicando, mejor dicho, la cantidad de cosas a las que pueden acceder porque podría estar otra persona. También hemos armado un espacio de consulta, de tal manera que si cualquiera de ustedes tiene alguna consulta específica sobre algún proyecto y quiere en forma reiterada que nosotros lo vayamos coachando, lo vamos a hacer semanalmente. Y bueno, hay un montón de horas, no me da la cuenta a mí, yo tenía como 500, un poco más, dijeron 1000, no tengo que hacer bien la cuenta, tengo que ser sincero, no sé si son 1000, pero eran más de 500, ¿sí? Y básicamente entonces tenemos, ahí cada uno de esos botones se abre, la página es ia.tuexitoprofesional.guru, no sé si la pueden pasar por el chat y por el canal de YouTube, pero básicamente ahí tienen todas las propuestas que vamos a hacer, las fechas de comienzo y la posibilidad de inscribirse. ¿Sí? Deep Learning, que como es nuestro curso estrella, el curso central de todo esto, que va a estar arrancando ahora en marzo junto con el resto de los cursos. Python para todos, que es un curso bien básico, que empieza bien de cero, o sea, para la gente que quizás o no tiene una base de programación, o quiere repasar, o quiere estudiarlo a fondo, es un curso que dura 6 meses y que va en detalle. Después tenemos la especialización en Project Management y la de Data Analytics, que son las que da la ingeniera Marina Siliti los sábados, que tienen, digamos, están basadas en las de Google y Coursera. O sea, ustedes van a poder obtener un certificado profesional, pero nosotros vamos a estar dándolo todo con contenidos propios desarrollados por la ingeniera Marina Siliti. El de Data Analytics también es un curso muy básico que empieza de cero, trabajando con plantillas, con planillas Excel y avanzando en las herramientas. La diferencia es que este está dado con R, no usa Python, pero tampoco es fundamental la parte de programación, hay muchas herramientas visuales, es un curso muy, muy completo, hecho por la gente de Google. Obviamente que es importante tener habilidades para manejar y gestionar proyectos, o por lo menos, si no van a gestionarlos ustedes, conocer cuál es el lenguaje que se maneja en la gestión de proyectos. Y después tenemos el grupo de los sábados de TensorFlow, que es un grupo de estudio que se reúne, donde la propuesta es hacer 4 especializaciones, 2 ahora y 2 en el segundo semestre. Data Deployment, son todas de Deep Learning y AI, como nombraba Emiliano Pasarello. Y, ¿qué más? Tenemos todo el ciclo de cursos de Ariel Teno, ¿sí? Que va a ser introducción con Python, que es ahora empezando en marzo. Después viene análisis de datos, que es un curso que también vamos a dar ahora a partir de esta semana.
Que está muy
Análisis
bueno
de
porque se ven todas las
Sí, dale.
herramientas para análisis de datos y para Machine Learning. Todo lo introducido se ve Pandas, Matplotlib, NumPy, todas las herramientas, Simboard. Genial.
Muy bien. Y Machine Learning, el curso de Machine Learning, que yo diría que es imperdible, es un curso relativamente corto frente al resto, pero hay un montón de herramientas interesantes para aprender y para trabajar, y se usa mucho todavía. No se crean que es todo Deep Learning, se usa muchísimo. Y un curso más avanzado de Python, complementario, interesante también, cerrando el ciclo de cursos de Ariel Teno. Después, los días lunes, que esto forma parte de Deep Learning, va a haber un ciclo de seminarios dados por Omar Facito, que realmente me encantaría que traten de no perdérselo, donde vamos a ver los temas de Deep Learning, pero vamos a ver de una forma más relajada, digamos, no digamos, ciñéndonos al programa, sino tratando de centrarnos en entender cómo funcionan estos algoritmos de inteligencia artificial. Y como frutilla al postre hemos agregado recientemente blockchain. Si vamos dando el curso de blockchain los días viernes, en cuatro meses, y bueno, obviamente que esto es una cosa nueva, pero me parece que agrega muchísimo valor. Y básicamente, digamos, los 4 pilares de los que nosotros hablamos son los cursos, estos cursos con un seguimiento, digamos, con un apoyo, como estamos haciendo ahora, la comunidad, que no es solo los que están cursando, sino hay miles de alumnos, miles de gente participando en los foros y en los grupos de correo y de WhatsApp. Los cursos de Coursera, que son más de 8.500, que realmente los mejores cursos de las mejores universidades del mundo están ahí. Ustedes van a poder obtener certificados oficiales a nombre de ustedes sin hacer un pago adicional, está incluido. Y las prácticas, lo que decimos de la cooperativa, que para nosotros es fundamental, que ustedes puedan trabajar y puedan participar en proyectos concretos para poder adquirir experiencia, para digamos, poder mostrarlo como una experiencia concreta en su currículum que trabajaron en un proyecto. Todo eso, digamos, el precio de lista es de $745 o 10 cuotas de $99, pero hay una oferta que les vamos a hacer. Hay una opción en pesos para gente de Argentina, porque hay gente que esto de PayPal no funciona, no lo permiten, así que hay una opción en pesos también por Mercado Pago o por transferencia. Y bueno, si querés abramos la opción de contado. La opción de contado muestra que si ahí tenés que llenar algo, poner un nombre, un mail, si no, no te deja pasar. Bien, vamos a paso 2. Bien, y aplicar cupón, ahí le tenés que poner temporada 2022 y le da un descuento, creo que es un descuento muy interesante, esto cubre todo el año, el acceso a Coursera, las consultorías. El precio de oferta que está por estos días es de $597, ¿sí? Como les decía, hay un precio en pesos, y después hay otro precio que es sacando Deep Learning y sacando el beneficiario. Si vos ponés ahí simple 2022, creo que no te deja, son $100 menos. O sea, para la gente que no va a hacer ahora Deep Learning, si le ponen ahí simple 2022, te da $497. Así que bueno, para los que quieran aprovecharlo, está abierto en este momento la inscripción, estamos arrancando en los próximos días, y bueno, aprovechenlo. Así que bueno, gracias Emiliano. Lo que sí les voy a pedir, por favor, a los que falta, que se anoten al grupo de WhatsApp, ahí se los voy a pasar, y que den el presente, porque les vamos a seguir invitando a los que dieron el presente, les vamos a mandar el link. Ahí está, les paso el link. Hay 96 personas, un montón. Tomamos 60 presentes. Lo paso por acá, ahí salió para todos, y también por el grupo el canal de YouTube, ¿sí? Les pido por favor que se sumen y que den el presente, así podemos continuar este curso que está dando Emiliano, que va a ser el viernes, hasta el viernes, o sea, lunes, martes, jueves y viernes. Bueno, te dejo, Emiliano, que continúes.
Bueno, muchísimas gracias, Ariel. Continuamos.
Pero fíjate que hay una pregunta de Jimena en el que yo te puse en el chat, Emi. Y bueno, Israel Amado, que pide explicación sobre los conjuntos de datos.
Que se me mutea, no entiendo qué pregunta sobre el conjunto de datos.
No, la primera pregunta de Jimena dice, respecto a las bases de datos, si se ingresan datos estructurados y no estructurados. No sé, supongo que será la diferencia, ¿no?
Hay bases de datos que son solamente generalmente las bases de datos SQL son datos estructurados, ¿no? Tipo columnas. Y hay bases de datos no estructurados, que son las no SQL, como yo conozco MongoDB y hay otras más, que guardan datos no estructurados. Igual en Postgres también se pueden guardar datos no estructurados y tiene campos especiales. Bueno, pero hay un montón de tecnologías y aparte, cuando hablamos de datos, de muchos datos, también está, ¿cómo se llama? La parte, el Big Data y los datos fraccionados, distribuidos. Pero en definitiva, uno recompila los datos para generar el algoritmo. Por ejemplo, el algoritmo no me acuerdo cómo se llama, el GTP3, que hace el chat, está procesado, con más de 400 terabytes de datos. Tomaron todos los datos que había en internet y analizaron. Pero eso lo hizo una empresa grande, grosa, ¿no? Tipo Google. Pero bueno, y después, ¿cuál era la otra pregunta?
No, también sobre los conjuntos de datos, imagino que van al mismo sentido.
Claro, sí, bueno, eso todo dependerá del trabajo que quieras hacer, del algoritmo que quieras hacer. Igual, ahora ya vamos a ver un poco más, después son 4 semanas, esta es la primera, vimos nada más que el principio, ya nos va a ir aclarando más cosas con respecto a los datos, con respecto a los algoritmos. Vamos a seguir entonces.
What makes a company good at AI? And perhaps even more importantly, what will it take for your company to become great at using AI? I had previously led the Google Brain team and Baidu's AI group, which had respectively helped Google and Baidu become great AI companies. So what can you do for your company? There's a lesson I had learned watching the rise of the internet that I think will be relevant to how all of us navigate the rise of AI. Let's take a look. A lesson we learned from the rise of the internet was that if you take your favorite shopping mall, so my wife and I sometimes shop at Stanford Shopping Center, and you build a website for the shopping mall, maybe sell things on the website, that by itself does not turn the shopping mall into an internet company. In fact, a few years ago, I was speaking with the CEO of a large retail company who said to me, "Hey, Andrew, I have a website. I sell things on the website. Amazon has a website. Amazon sells things on the website. It's the same thing." But of course it wasn't. And a shopping mall with a website isn't the same thing as a first-class internet company. So what is it that defines an internet company if it isn't just whether or not you sell things on the website? I think an internet company is a company that does the things the internet lets you do really well. For example, we engage in pervasive A/B testing, meaning we routinely throw up 2 different versions of a website and see which one works better, because we can, and so we learn much faster. Whereas in a traditional shopping mall, it's very difficult to have 2 shopping malls in 2 parallel universes, and you can only maybe change things around every quarter or every 6 months. Internet companies tend to have very short iteration times. You can ship a new product every week or maybe even every day because you can. Whereas a shopping mall can be redesigned and re-architected only every several months. Internet companies also tend to push decision-making down from the CEO to the engineers and to other specialized roles, such as the product managers. This is in contrast to a traditional shopping mall where you can maybe have the CEO just decide all the key decisions and then just everyone does what the CEO says. And it turns out that traditional model doesn't work in the internet era because only the engineers and other specialized roles like product managers know enough about the technology and the product and the users to make great decisions. So these are some of the things that internet companies do in order to make sure they do the things that the internet lets them do really well. This is a lesson we learned from the internet era. How about the AI era? I think that today you can take any company and have it use a few neural networks or a few deep learning algorithms. That by itself does not turn the company into an AI company. Instead, what makes a great AI company, sometimes an AI first company, is, are you doing the things that AI lets you do really well? For example, AI companies are very good at strategic data acquisition. This is why many of the large consumer tech companies may have free products that do not monetize, and it allows them to acquire data that they can monetize elsewhere. So I've led strategy teams where we would deliberately launch products that do not make any money just for the sake of data acquisition. And thinking through how to get data is a key part of the great AI companies. AI companies tend to have unified data warehouses. If you have 50 different databases or 50 different data warehouses under the control of 50 different vice presidents, then it'll be impossible for an engineer to get the data into one place so that they can connect the dots and spot the patterns. So many great AI companies have preemptively invested in bringing the data together into a single data warehouse to increase the odds that the teams can connect the dots. Subject, of course, to privacy guarantees and also to data regulations such as GDPR in Europe. AI companies are very good at spotting automation opportunities. We're very good at seeing, oh, let's insert a supervised learning algorithm and have an A to B mapping here so that we don't have to have people do these tasks. Instead, we can automate it. AI companies also have many new roles, such as the MLE or machine learning engineer, and new ways of dividing up tasks among different members of a team. So for a company to become good at AI means architecting the company to do the things that AI makes it possible to do really well. Now, for a company to become good at AI does require a process. In fact, 10 years ago, Google and Baidu, as well as companies like Facebook and Microsoft that I was not a part of, were not great AI companies the way that they are today. So how can a company become good at AI? It turns out that becoming good at AI is not a mysterious, magical process. Instead, there is a systematic process through which many companies, almost any big company, can become good at AI. This is the 5-step AI transformation playbook that I recommend to companies that want to become effective at using AI. I'll give a brief overview of the playbook here and then go into detail in a later week. Step 1 is to execute pilot projects to gain momentum. So just do a few small projects to get a better sense of what AI can and cannot do and get a better sense of what doing an AI project feels like. And this you could do in-house or you can also do with an outsourced team. But eventually you then need to do step 2, which is to build an in-house AI team and provide broad AI training, not just to the engineers, but also to the managers, division leaders, and executives on how to think about AI. After doing this, or as you're doing this, you have a better sense of what AI is, and then it's important for many companies to develop an AI strategy. And finally, to align internal and external communications so that all your stakeholders, from employees, customers, and investors, are aligned with how your company is navigating the rise of AI. AI has created tremendous value in the software industry and will continue to do so. It will also create tremendous value outside the software industry. If you can help your company become good at AI, I hope you can play a leading role in creating a lot of this value. In this video, you saw what is it that makes a company a good AI company, and also briefly the AI transformation playbook, which I'll go into much greater detail on in a later week as a roadmap for helping companies become great at AI. If you're interested, there is also published online an AI transformation playbook that goes into these 5 steps in greater detail, but you'll see more of these in a later week as well. Now, one of the challenges of doing AI projects, such as the pilot projects in step 1, is understanding what AI can and cannot do. In the next video, I want to show you and give you some examples of what AI can and cannot do to help you better select projects for AI that may be effective for your company. Let's go on to the next video.
Bueno, una introducción a lo que el aprendizaje automático puede, bueno, eso es lo que viene después, ¿no? Cómo una empresa se puede llevar bien, puede ser buena en inteligencia artificial. Entonces, él propone 5 pasos, que uno es empezar a hacer trabajos pilotos para mostrar qué es lo que se puede hacer y lo que no se puede hacer con inteligencia artificial y tener éxito rápido con algún algoritmo y después ir avanzando. Eso que va avanzando lo vamos a ir viendo ahora a medida que van avanzando los videos, va a ir explicando los distintos pasos. Así que recomiendo que continuemos y cualquier duda me pueden preguntar o Ariel y yo podemos responder. Continuamos.
In this video and the next video, I hope to help you develop intuition about what AI can and cannot do. In practice, before I commit to a specific AI project, I'll usually have either myself or engineers do technical diligence on a project to make sure that it is feasible. This means look at the data, look at the input and output A and B, and just thinking through if this is something AI can really do. What I've seen, unfortunately, is that some CEOs can have an overinflated expectation of AI and can ask engineers to do things that today's AI just cannot do. One of the challenges is that the media, as well as the academic literature, tends to only report on positive results or success stories using AI. And we see a string of success stories and no failure stories. People sometimes think AI can do everything. And unfortunately, that's just not true. So what I want to do in this and the next video is to show you a few examples of what today's AI technology can do, but also what it cannot do. And I hope that this will help you hone your intuition about what might be more or less promising projects to select for your company. Previously, you saw this list of AI applications, from spam filtering to speech recognition to machine translation, and so on. One imperfect rule of thumb you can use to decide what supervised learning may or may not be able to do is that pretty much anything you could do with a second of thought, we can probably now or soon automate using supervised learning, using this input-output mapping. So, for example, in order to determine the position of other cars, that's something that you can do with less than a second. In order to tell if a phone is scratched, you can look at it and you can kind of tell in less than a second. In order to understand, or at least transcribe what was said, it doesn't take that many seconds of thought. And while this is an imperfect rule of thumb, it maybe gives you a way to quickly think of some examples of tasks that AI systems can do. Whereas in contrast, something that AI today cannot do would be to analyze a market and write a 50-page report. A human cannot write a 50-page market analysis report in a second, and it's very difficult. At least I don't know. And I don't think any team in the world today knows how to get an AI system to do market research and run an extended market report either. I found that one of the best ways to hone intuition is to look at concrete examples. So let's take a look at a specific example relating to customer support automation. Let's say you run a website that sells things, so an e-commerce company, and you have a customer support division that gets an email like this. The toy arrived 2 days late, so I wasn't able to give it to my niece for her birthday. Can I return it? If what you want is an AI system that looks at this and decides this is a refund request, so let me route it to my refund department, then I would say you have a good chance of building an AI system to do that. The AI system would take as input the customer text, what the customer emailed you, and it would output, is this a refund request, or is this a shipping problem, or is it a other request in order to route this email to the most appropriate part of your customer support center. So the input A is the text, and the output B is one of these three outcomes. Is it a refund or a shipping problem or a shipping query, or is it a different request? So this is something that AI today can do. Here's something that AI today cannot do, which is if you want the AI to input an email and automatically generate a response like, oh, sorry to hear that. I hope your niece had a good birthday. Yes, we can help with, and so on. So for an AI to output a complicated piece of text like this today is very difficult by today's standards of AI. And in fact, to even empathize about the birthday of your niece, that is very difficult to do for every single possible type of email you might receive. Now, what would happen if you were to use a machine learning tool, like a deep learning algorithm, to try to do this anyway? So let's say you try to get an AI system to input the user's email and output a 2 to 3 paragraph empathetic and appropriate response. And let's say that you have a model-sized data set, like 1,000 examples of user emails and appropriate responses. It turns out if you run an AI system on this type of data, on a small data set, like 1,000 examples, this may be the performance you get, which is if a user emails, my box is damaged, it'll say, thank you for your email. If it says, whether I write a review, thank you for your email. What's the return policy? Thank you for your email. But the problem with building this type of AI is that with just 1,000 examples, there's just not enough data for an AI system to learn how to write 2 to 3 paragraph appropriate and empathetic responses. So it may end up just generating the same very simple response like thank you for your email, no matter what the customer is sending you. Another thing that could go wrong, another way for an AI system to fail, is if it generates gibberish, such as, when are my box arriving? And it says, thank, yes, now, your kind of gibberish. And this is a hard enough problem that even with 10,000 or 100,000 email examples, I don't know if that would be enough data for an AI system to do this well. The rules for what AI can and cannot do are not hard and fast. And I usually end up having to ask engineering teams to sometimes spend a few weeks doing deep technical diligence to decide for myself if a project is feasible. But to hone your intuitions, to help you quickly filter feasible and not feasible projects, here are a couple other rules of thumb about what makes a machine learning problem easier or more likely to be feasible. 1, learning a simple concept is more likely to be feasible. Well, what does a simple concept mean? There's no formal definition of that, but if it's something that takes you less than a second of mental thought, or a very, very small number of seconds of mental thought to come up with a conclusion, then that would lean toward it being a simple concept. So you're looking outside the window of a self-driving car to spot the other cars. That would be a relatively simple concept. Whereas how to write an empathetic response to a complicated user complaints, that would be less of a simple concept. Second, a machine learning problem is more likely to be feasible if you have lots of data available. And here, data means both the input A and the output B that you want the AI system to have in your A to B input-output mapping. So, for example, in the customer support application, the input A would be examples of emails from customers, and B could be labeling each of these customer emails as to whether it is a refund request or a shipping query or some other problem, one of 3 outcomes. And if you have thousands of emails with both A and B, then the odds of you being able to build a machine learning system to do that would be pretty good. AI is the new electricity and is transforming every industry, but it's also not magic and it can't do everything under the sun. I hope that this video started to help you hone your intuitions about what it can and cannot do and increase the odds of your selecting feasible and valuable projects for maybe your teams to try working on. In order to help you continue developing your intuition, I would like to show you more examples of what AI can and cannot do. Let's go on to the next video.
Bueno, lo que dice, lo que no sé, bueno, si alguien quiere comentar, comente. Pero lo que yo entendí es que no es tan fácil saber qué es lo que puede hacer la inteligencia artificial o no, porque todo depende de la cantidad de datos que tengamos y la complejidad de lo que sea el proceso. Si es un proceso simple para nosotros, es lo más probable que la inteligencia artificial lo pueda resolver. Pero, como explicaba, escribir un email empático, una respuesta empática de un email complicado, a veces nos cuesta. Entonces, para que una inteligencia artificial pueda resolver eso, necesita muchos datos y mucho entrenamiento, ¿no? Y al principio va a ser un desastre, va a responder cualquier cosa, y a medida que vaya, entonces, siempre hay que analizar lo que tenemos, lo que queremos lograr, y de qué datos, cuántos datos partimos y cómo podemos ir a avanzar. Porque esto avanza muy rápido, todo avanza muy rápido. Ahora existen los transformers que hicieron una revolución el año pasado terrible en el Natural Language Processing. Entonces, hace poco hemos visto de que hay sistemas de transformers que reciben un conjunto de mail, como el que mostraba Andrew recién, y pueden llegar a contestar cosas coherentes que sean relacionadas. Y y eso cuando no existía cuando se creó este curso, que tampoco tiene mucho tiempo, ¿no? Ariel, no sé cuánto tiempo tiene este curso, pero...
Sí, este curso en realidad Andrew lo hizo después de hacer la especialización en Deep Learning, por eso nosotros habíamos hecho un curso parecido a este, o que quería hacer esto. Fue nuestro primer curso que hablaba de justamente qué era la inteligencia artificial, las implicancias sociales. Y después salió este, que es, en realidad este curso es paralelo a cuando Andrew lanzó su empresa, ¿no? Lending AI. Pero sí, es cierto que cuando hizo este curso, la tecnología de Transformer todavía era una idea, y eso explotó después de hacerse este curso, totalmente.
Y salió el grupo que creó él en Google Bryant, porque de Google Bryant fueron los que desarrollaron lo que fueron no sé si fueron los únicos que hicieron el paper de Transformers. Y gracias al paper de Transformers, que fue creciendo, se hizo el GTP2, el GTP3, y algoritmos que acá cuando vemos en el video, ¿no, Ariel? Cuando vemos el video que dice que eso no lo podría hacer una inteligencia artificial, y hace poquito vimos que más o menos lo están haciendo. Así que esto es un avance continuo y sin descanso de la inteligencia artificial.
Sí, bueno, desde ya que uno dice algo hoy, y todo hay que tomarlo con pinzas, porque dentro de 6 meses a lo mejor salió algo que realmente sí se pudo hacer. O sea, es un campo en el que se está invirtiendo mucho, se está creciendo mucho, y hay muchas cosas que se están desarrollando y que se están logrando. El canal que, bueno, nosotros usamos como referencia es .csv, el canal de YouTube, ¿no? .csv. Y las novedades que salen son impresionantes.
Y el otro día salió el video de la inteligencia artificial que programa sola, que resuelve el problema de que resuelve el problema de algoritmos de, ¿cómo se llaman? Las competencias de programación. Así que bueno, da miedo. Bueno, seguimos. Ani puso la pizarra, bueno, pero vamos a seguir, no molesta, ¿no?
One of the challenges of becoming good at recognizing what AI can and cannot do is that it does take seeing a few examples of concrete successes and failures of AI. And if you work on an average of, say, 1 new AI project a year, then to see 3 examples would take you 3 years of work experience, and that's just a long time. What I hope to do, both in the previous video and in this video, is to quickly show you a few examples of AI successes and failures, or of what it can and cannot do, so that in a much shorter time, you can see multiple concrete examples to help hone your intuition and select valuable projects. So let's take a look at a few more examples. Let's say you're building a self-driving car. Here's something that AI can do pretty well, which is to take a picture of what's in front of your car, and maybe just using a camera, maybe using other sensors as well, such as radar or LiDAR, and then to figure out what is the position or where are the other cars. So this would be an AI where the input A is a picture of what's in front of your car, or maybe both a picture as well as radar and other sensor readings, and the output B is where are the other cars. And today, the self-driving car industry has figured out how to collect enough data and has pretty good algorithms for doing this reasonably well. So that's what AI today can do. Here's an example of something that today's AI cannot do, or at least would be very difficult using today's AI, which is to input a picture and output the intention or whatever the human is trying to gesture at your car. So here's a construction worker holding out a hand to ask your car to stop. Here's a hitchhiker trying to wave a car over. Here's a bicyclist raising the left hand to indicate that they...
Sí, Javier, te escucho.
¿Esta parte no tenía subtítulos o se fueron?
Está cortada la imagen.
Alina, voy a dejar de compartir la pantalla porque no sé, alguien toca la
pizarra. Sí, alguien te toca la pantalla y se te va de resolución, ¿no?
Entonces, voy a dejar de compartir y vuelvo a compartir. ¿Listo?
No, dale, ok.
Gracias por avisar. Y pongo de vuelta todo el video de entrada. Ahí está.
One of the challenges of becoming good at recognizing what AI can and cannot do is that it does take seeing a few examples of concrete successes and failures of AI. And if you work on an average of, say, one new AI project a year, then to see 3 examples would take you 3 years of work experience, and that's just a long time. What I hope to do, both in the previous video and in this video, is to quickly show you a few examples of AI successes and failures, or what it can and cannot do, so that in a much shorter time, you can see multiple concrete examples to help hone your intuition and select valuable projects. So let's take a look at a few more examples. Let's say you're building a self-driving car. Here's something that AI can do pretty well, which is to take a picture of what's in front of your car, and maybe just using camera, maybe using other sensors as well, such as radar or LiDAR, and then to figure out what is the position or where are the other cars. So this would be an AI where the input A is a picture of what's in front of your car, or maybe both a picture as well as radar and other sensor readings, and the output B is where are the other cars. And today, the self-driving car industry has figured out how to collect enough data and has pretty good algorithms for doing this reasonably well. So that's what AI today can do. Here's an example of something that today's AI cannot do, or at least would be very difficult using today's AI, which is to input a picture and output the intention or whatever the human is trying to gesture at your car. So here's a construction worker holding out a hand to ask your car to stop. Here's a hitchhiker trying to wave a car over. Here's a bicyclist raising the left hand to indicate that they want to turn left. And so if
Hola, ¿me escuchan? ¿Se ven subtítulos?
Sí, pero ahora se ve raro. Se dejó de escuchar recién.
Ah, no. Está bien. No,
if you were to try to build a system to learn an A to B mapping, where the input A is a short video of a human gesturing at your car, and the output B is what's the intention, what does this person want.
Hay alguien que toca para poner la pizarra y...
¿Vos sos el host o Ariel?
A ver.
¿O lo podés...?
No, el
si
host
tenés
es Ariel.
No, le paso el host a Emiliano y con eso lo resolvemos.
Dale, ahí sacale. Sí, está bien.
Ok, listo. Entonces ahora sí. Dígame, ¿desde dónde se dejó de ver otra vez? El problema soy yo entonces.
Ahí en esa parte.
¿Pero se está viendo toda la pantalla?
Ahora no, ahora se ve cortado. En esta parte donde empieza a fallar.
That today is very difficult to do. Part of the problem is that the number of ways people gesture at you is very, very large. Imagine all the hand gestures someone could conceivably use, ask you to slow down or go or stop. The number of ways that people could gesture at you is just very, very large. And so it's difficult to collect enough data from enough thousands or tens of thousands of different people gesturing at you in all of these different ways to capture the richness of human gestures. So learning from a video to what this person wants is actually a somewhat complicated concept. In fact, even people have a hard time figuring out sometimes what someone waving at your car wants. And then second, because this is a safety critical application, you would want an AI that is extremely accurate in terms of figuring out, does a construction worker want you to stop or does he or she want you to go? And that makes it harder for an AI system as well. And so today, if you collect just say 10,000 pictures of other cars, many teams will be able to build an AI system that at least has a basic capability at detecting other cars. In contrast, even if you collect pictures or videos of 10,000 people, it's quite hard to track down 10,000 people waving at your car. Even with that data set, I think it's quite hard today to build an AI system to recognize human intention from their gestures at the very high level of accuracy needed in order to drive safely around these people. So that's why today, many self-driving car teams have some components for detecting other cars, and they do rely on that technology to drive safely. But very few self-driving car teams are trying to count on an AI system to recognize a huge diversity of human gestures and counting just on that to drive safely around people. Let's look at one more example. Say you want to build an AI system to look at X-ray images and diagnose pneumonia. So all of these are chest X-rays. So the input A could be the X-ray image and the output B can be the diagnosis. Does this patient have pneumonia or not? So that's something that AI can do. Something that AI cannot do would be to diagnose pneumonia from 10 images of a medical textbook chapter explaining pneumonia. A human can look at a small set of images, maybe just a few dozen images, and read a few paragraphs from a medical textbook and start to get a sense. But I actually don't know, given a medical textbook, what is A and what is B, or how to really pose this as an AI problem that know how to write a piece of software to solve if all you have is just 10 images and a few paragraphs of text that explain what pneumonia in a chest X-ray looks like. Whereas a young medical doctor might learn quite well reading a medical textbook and just looking at, maybe dozens of images. In contrast, an AI system isn't really able to do that today. To summarize, here are some of the strengths and weaknesses of machine learning. Machine learning tends to work well when you're trying to learn a simple concept, such as something that you could do with less than a second of mental thought, and when there's lots of data available. Machine learning tends to work poorly when you're trying to learn a complex concept from small amounts of data. A second underappreciated weakness of AI is that it tends to do poorly when it's asked to perform on new types of data that's different than the data it has seen in your data set. Let me explain with an example. Say you built a supervised learning system that uses A to B to learn to diagnose pneumonia from images like these. These are pretty high quality chest X-ray images. But now let's say you take this AI system and apply it at a different hospital or a different medical center where maybe the X-ray technician somehow strangely had the patients always lie at an angle, or sometimes there are these defects. Not sure if you can see the little scratches in the image, these little other objects lying on top of the patients. If the AI system has learned from data like that on your left, maybe taken from a high quality medical center, and you take this AI system and apply it to a different medical center that generates images like those on the right, then its performance will be quite poor as well. A good AI team will be able to ameliorate or to reduce some of these problems, but doing this is not that easy. And this is one of the things that AI is actually much weaker than humans. If a human has learned from images on the left, they're much more likely to be able to adapt to images like those on the right as they figure out that the patient's just lying at an angle. But an AI system can be much less robust than human doctors in generalizing or figuring out what to do with new types of data like this. I hope these examples are helping you hone your intuitions about what AI can and cannot do. In case the boundary between what it can and cannot do still seems fuzzy to you, don't worry, that's completely normal, completely okay. In fact, even today, I still can't look at a project and immediately tell if something is feasible or not. And I often still need small numbers of weeks of technical diligence before forming strong conviction about whether something is feasible or not. But I hope that these examples can at least help you start imagining some things in your company that might be feasible and might be worth exploring more. The next two videos after this are optional and are a non-technical description of what are neural networks and what is deep learning. Please feel free to watch those. And then next week, we'll go much more deeply into the process of what building an AI project would look like. Look forward to seeing you next week.
Bueno, si para él es difícil y se toma 2 semanas para ver si un proyecto de inteligencia artificial es viable, para nosotros que recién estamos viendo esto, que estamos empezando, va a ser más difícil. Tenemos que ver. Pero es muy claro el ejemplo que dio de las radiografías. Que si un algoritmo está entrenado viendo un tipo de radiografías de una posición y le vamos a mostrar radiografías giradas en otra posición, el rendimiento va a ser totalmente deficiente. Entonces siempre tenemos que, el algoritmo tiene que entrenarse con la mayor cantidad de imágenes, la mayor cantidad de datos posible y con los datos que va a encontrar después en la realidad, ¿no? ¿Se entendió o alguien tiene alguna duda, algún comentario? ¿No? ¿Todo perfecto? ¿Qué opinan ustedes? ¿No opinan nada? Bueno.
No, está muy interesante y está bien explicado. Me parece que resumen bien hasta ahora los temas que vamos viendo.
Está bien, listo. Bueno, ahora creo que son 2 videos más que en realidad son opcionales, pero lo vamos a ver porque tenemos tiempo y entonces nos van a explicar explicación no técnica del aprendizaje profundo, parte 1.
The terms deep learning and neural network are used almost interchangeably in AI. And even though they're great for machine learning, there's also been a bit of hype and a bit of mystique about them. This video will demystify deep learning so that you have a sense of what deep learning and neural networks really are. Let's use an example from demand prediction. Let's say you run a website that sells t-shirts and you want to know, based on how you price the t-shirts, how many units you expect to sell, how many t-shirts you expect to sell. You might then create a data set like this, where the higher the price of the t-shirt, the lower the demand. So you might fit a straight line to this data, showing that as the price goes up, the demand goes down. Now, demand can never go below 0, so maybe you say that the demand will flatten out at 0, and beyond a certain point, you expect, pretty much no one to buy any t-shirts. It turns out this blue line is maybe the simplest possible neural network. You have as input the price, A, and you want it to output the estimated demand, B. So the way you would draw this as a neural network is that the price would be input to this little round thing there, and this little round thing outputs the estimated demand. In the terminology of AI, this little round thing here is called a neuron, or sometimes it's called an artificial neuron, and all it does is compute this blue curve that I've drawn here on the left. This is maybe the simplest possible neural network with a single artificial neuron that just inputs the price and outputs the estimated demand. If you think of this orange circle, this artificial neuron, as a little Lego brick, all that a neural network is if you take a lot of these Lego bricks and stack them on top of each other until you get a big pile or a big network of these neurons. Let's look at a more complex example. Suppose that instead of knowing only the price of the t-shirts, you also have the shipping costs that the customers will have to pay to get the t-shirts. Maybe you spend more or less on marketing in a given week. And you can also make the t-shirt out of a thick, heavy, expensive cotton or a much cheaper, more lightweight material. These are some of the factors that you think will affect the demand for your t-shirts. Let's see what a more complex neural network might look like. You know that your customers care a lot about affordability. So let's say you have one neuron, and let me draw this one in blue, whose job it is to estimate the affordability of the t-shirts. And because affordability is mainly a function of the price of the shirt and of the shipping costs. A second thing that will affect the demand for your t-shirts is awareness. How much are consumers aware that you're selling this t-shirt? So the main thing that affects awareness is going to be your marketing. So let me draw here a second artificial neuron that inputs your marketing budget, how much you spent on marketing, and outputs how aware are consumers of your t-shirt. Finally, the perceived quality of your product will also affect demand, and perceived quality would be affected by marketing. If the marketing tries to convince people this is a high quality t-shirt, and sometimes the price of something also affects perceived quality. So I'm going to draw here a third artificial neuron that inputs price, marketing, and material and tries to estimate the perceived quality of your t-shirts. Finally, now that the earlier neurons, these three blue neurons, have figured out how affordable, how much consumer awareness, and what's the perceived quality, you can then have one more neuron over here that takes as input these three factors and outputs the estimated demand. So this is a neural network, and its job is to learn to map from these four inputs, that's the input A, to the output B, the demand. So it learns this input to output or A to B mapping. This is a fairly small neural network with just 4 artificial neurons. In practice, neural networks used today are much larger, with easily thousands, tens of thousands, or even much larger than that numbers of neurons. Now, there's just one final detail of this description that I want to clean up, which is that in the way I've described a neural network, it was as if you had to figure out that the key factors are affordability, awareness, and perceived quality. One of the wonderful things about using neural networks is that to train a neural network, in other words, to build a machine learning system using a neural network, all you have to do is give it the input A and the output B, and it figures out all of the things in the middle by itself. So to build a neural network, what you would do is feed it lots of data with the input A, and have a neural network that just looks like this, with a few blue neurons feeding to a yellow output neuron. And then you have to give it data with the demand B as well. And it's the software's job to figure out what these blue neurons should be computing so that it can completely automatically learn the most accurate possible function mapping from the input A to the output B. And it turns out that if you give this enough data and train a neural network that is big enough, this can do an incredibly good job mapping from inputs A to outputs B. So that's a neural network. It's a group of artificial neurons, each of which computes a relatively simple function, but when you stack enough of them together like Lego bricks, they can compute incredibly complicated functions that give you very accurate mappings from the input A to the output B. Now, in this video, you saw an example of neural networks applied to demand prediction. Let's go on to the next video to see a more complex example of neural networks applied to face recognition.
Bueno, quiero saber qué opinan, qué entendieron, si alguien me puede, quiero escucharlos participar, y si entendieron cómo es la estructura. ¿No? Nadie me puede decir nada.
Emiliano,
Sí, Gustavo.
ayuda.
Bueno.
Para mí, me lo imagino como que esa red neuronal artificial, esas pequeñas burbujas de color celeste que representan funciones, son, corregime si me equivoco, funciones, ecuaciones matemáticas conjuntas, interrelacionadas, que se disparan a partir de diversa cantidad de datos que entran para alimentar otra burbuja, la anaranjadita, que también es una ecuación y provoca el valor B.
Claro, sí, exactamente. Cada neurona. Sí, escucho.
Hola, yo quería participar.
Sí.
Creo que esto que se explicaba de la red neuronal es más que todo un tipo de datos de entradas y salidas como lo muestra A y B, y lo que está en medio, que vendrían a ser estas burbujas, como le llaman, que vendrían a ser las neuronas, vendría a ser un modelo matemático, ¿no? Un modelo matemático que puede ser programado en Python o en diferentes lenguajes que se han visto, donde se encargan de reducir o disminuir el error del modelo para poder obtener la salida B, que normalmente son llamados pesos.
¿Algún conocimiento tenés? Sí, en realidad todas las neuronas tienen una función, hacen un proceso matemático, una multiplicación matricial, bueno, pero no es técnico, y una función de activación. Lo interesante es que cuando nosotros aplicamos las neuronas, no decimos qué trabajo va a hacer cada neurona, no programamos qué trabajo va a hacer una neurona. En el primer paso, en lo que se llama entrenamiento, en el primer resultado va a ser malo la predicción que va a hacer. Pero ahí hay una función que se llama función de costo que va a calcular el error y va a hacer los arreglos, va a penalizar las neuronas que se equivocaron y va a ir modificando los pesos de esas neuronas, y a medida que el proceso iterativo va a ir mejorando el rendimiento de la red. ¿Entienden? Entonces, esto no es que aprendizaje profundo, machine learning, necesita aprender. Entonces, ¿cómo necesita aprender? Prueba y error, prueba y error, prueba y error, prueba y error, prueba y error. Entonces, a medida que tenemos la red neuronal, las capas, la cantidad de neuronas, hay muchos factores que dependen que después tenemos que empezar a tocar. ¿Entiendes? Entonces, eso es lo bueno que tiene, que en realidad no sabemos muy bien qué es lo que pasa dentro. Sabemos los cálculos matemáticos que ocurren, pero no sabemos qué neurona hace una cosa, qué neurona otra. Suponemos, hay gente que se investiga. Bueno, pero no me estoy yendo al tema, pero más o menos, ahora vamos a ver el segundo video, que es, dijo un poco más complejo. Vamos a empezar a ver. Este es el último.
In the last video, you saw how a neural network can be applied to demand prediction. But how can a neural network look at a picture and figure out what's in the picture, or listen to an audio clip and understand what is said in an audio clip? Let's take a look at a more complex example of applying a neural network to face recognition. Say you want to build a system to recognize people from pictures. How can a piece of software look at this picture and figure out the identity of the person in it? Let's zoom in to a little square like that to better understand how a computer sees pictures. Where you and I see a human eye, a computer instead sees that. It sees this grid of pixel brightness values that tells it for each of the pixels in the image, how bright is that pixel. If it were a black and white or a grayscale image, then each pixel would correspond to a single number telling you how bright is that pixel. If it's a color image, then each pixel would actually have 3 numbers corresponding to how bright are the red, green, and blue elements of that pixel. So the neural network's job is to take as input a lot of numbers like these and tell you the name of the person in the picture. In the last video, you saw how a neural network can take as input 4 numbers corresponding to the price, shipping cost, amount of marketing, and the cloth material of a t-shirt and output demand. In this example, the neural network just has to input a lot more numbers corresponding to all of the pixel brightness values of this picture. If the resolution of this picture is 1000 pixels by 1000 pixels, then that's 1,000,000 pixels. So if it were a black and white or a grayscale image, this neural network would take as input 1,000,000 numbers corresponding to the brightness of all 1,000,000 pixels in this image. Or if it was a color image, it would take as input 3,000,000 numbers corresponding to the red, green, and blue values of each of these 1,000,000 pixels in this image. Similar to before, you will have many of these artificial neurons computing various values. And it's not your job to figure out what these neurons should compute. The neural network will figure it out by itself. But typically, when you give it an image, the neurons in the earlier parts of the neural network will learn to detect edges in pictures, and then a little bit later, it'll learn to detect parts of objects. So it may learn to detect eyes and noses and the shape of cheeks and the shape of mouths. And then the later neurons, further to the right, will learn to detect different shapes of faces, and it will finally put all this together to output the identity of the person in the image. And again, part of the magic of neural networks is that you don't really need to worry about what it is doing in the middle. All you need to do is give it a lot of data of pictures like this, A, as well as of the correct identity, B, and the learning algorithm will figure out by itself what each of these neurons in the middle should be computing. Congratulations on finishing all the videos for this week. You now know how machine learning and data science work. I look forward to seeing you in next week's videos as well, where you learn how to build your own machine learning or data science project. See you next week.
¿Qué tal, Emiliano?
Sí, Ariel.
No, si querías decir algo, dale.
No, sí, dale.
Se viene el examen, ¿no?
Sí, se viene el examen.
Bueno, la verdad que yo estoy sorprendido por la cantidad de gente, es re lindo, tanta gente, está bueno. La verdad que es un gran curso, yo siempre recomiendo que empiecen con este curso, porque no es un curso técnico, es muy general. Y como comentario que les quiero decir hoy, casi 90 y pico personas, 88, un montón, 90. Está empezando un curso este miércoles, ¿sí? Miércoles y jueves va a ser análisis de datos con Python, o sea, Data Analytics con Python. Es un curso de 6 clases que va a dar Ariel Tenon. Empieza el miércoles con un repaso general de Python. Después son 4 clases donde se van a ver las bibliotecas principales para manejo de datos de Python, que son NumPy, Pandas, Matplotlib y Born. Y la última clase, que es el 3 de marzo, va a ser una presentación general de Machine Learning. La clase va a ser abierta, la de este miércoles, la de Python, por eso nosotros no vamos a dar clase ese día. Si tienen interés en meterse en ese curso, que en realidad es un curso que lo planteamos exclusivo para nuestros suscriptores que ya compraron la temporada y fue un adicional, les sugiero que se pongan en contacto con alguna de la gente de coordinación de cursos, porque me parece que es una buena oportunidad para arrancar los que tengan ganas de empezar con estos temas, ¿sí? ¿Vamos al examen?
Vamos al examen, pero
¿Qué faltó?
Mucha participación,
Ah, claro, sí, ahora son ustedes los que tienen que responder.
Bueno. ¿Cuál de estos términos describe mejor y si quieren ahora pueden dar sus opiniones, compartir ideas? Tenemos unos minutitos, no mucho, pero y si no, nos voy pidiendo hasta mañana. Bueno, entonces nos despedimos hasta mañana.
Muchas gracias.
Espero que les
Muchas
haya
gracias.
gustado todo.
Sí, muy bueno, muy claro. Gracias.
Muchísimas gracias a todos.
Muchas gracias.